So in this video, we're going to put together some conclusions we've already made. Namely, we've already figured out where this improper integral is divergent, and we did that in two places. So we covered the case where p is equal to 1 in the video you're seeing above now. So if you haven't watched it and would like to watch it, there should be a link coming up on your screen. But for this case, we know the integral from 1 to infinity of 1 over x dx is divergent. We've also covered the case where p is less than 1. And again, that was in a previous video, so if you haven't seen it, please avail yourself of the link coming up now. In this case, this improper integral is also divergent. So now all that's left to check is the case where p is greater than 1. So now the first thing we need to do is rewrite this integral as a limit. That is the limit as t approaches infinity of the integral from 1 to t of 1 over x to the p dx. And this is equal to the limit as t approaches infinity of the integral from 1 to t of x to the negative p dx. Undoing the power rule yields x to the negative p plus 1 divided by negative p plus 1. And we still have this limit out in front. And of course, we're evaluating from 1 to t. We can continue. Now, I've split this into two separate limits, and I've also done some ninja algebra here. That is, a 1 minus p is equal to negative p minus 1. And I took advantage of that in two places. I rewrote this exponent here as its opposite. And this denominator here, 1 minus p, I wrote it as negative p minus 1. Well, how does this help us? Well, the denominator in both cases is just a constant, so when I rewrite this in the next step, I'm going to move these out to the front just so they're not distracting us visually. Okay, and now I left off what goes inside of these limits. So here I have t raised to a negative exponent. To make it positive, I can move this entire quantity to the denominator. And then here I factored out this denominator of p minus 1, and I'm left with negative 1 over negative 1, so it's just 1. As t approaches infinity, 1 over t to the p minus 1 power is going to approach 0. So this entire limit is 0. And then here we know the limit of a constant is just that constant. So this evaluates to just 1 over p minus 1 times 1 is just 1 over p minus 1. Since this is a finite value, we know this integral converges for values of p larger than 1. So now that we've done all of these three cases separately, I'm going to condense them into two. So there we have it. If p is less than or equal to 1, then this integral is divergent. If p is greater than 1, then this integral is convergent. This is definitely a key concept to remember. So please write this down somewhere, highlight it, tab it with a Post-it note, anything so you can remember this. I hope this video was helpful.